Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young. Chapter 4, Harmonic Constructions and the Fundamental Theorem of Projective Geometry. Section 38, Involutions. Definition: if a projectivity in a one-dimensional form is of period 2, it is called an involution. Any pair of homologous points of an involution is called a conjugate pair of the involution, or a pair of conjugates. It is clear that if an involution transforms a point A into A', then it also transforms A' into A. This is expressed by the phrase that the points A and A' correspond to each other doubly. The effect of an involution is then simply a pairing of elements of a one-dimensional form such that each element of a pair corresponds to the other element of the pair. This justifies the expression a conjugate pair applied to an involution. Theorem 26. If for a single point A of a line which is not a double point of a projectivity π on the line, we have the relations π of A equal to A' and π of A' equal to A, the projectivity is an involution. Assumptions A, E, and P. Proof: for suppose P is any other point on the line, not a double point of π, and suppose π of P is equal to P', there then exists a projectivity giving A' P projective with A', P', by Theorem 2 of Chapter 3. By Theorem 17, this projectivity is π, since it has the three pairs of homologous points A', A', P'. But in this projectivity, P' is transformed into P. Thus every pair of homologous points correspond doubly. Corollary: an involution is completely determined when two pairs of conjugate points are given. Assumptions A, E, and P. Theorem 27. A necessary and sufficient condition that three pairs of points A', B', C', be conjugate pairs of an involution is Q of ABC, A', B', C'. Assumptions A, E, and P. Proof: by hypothesis, we have A', BC is projective with A', B', C'. By Theorem 2 of Chapter 3, we also have A', B', C' projective with A', C', B', which, with the first projectivity, gives A', BC projective with A', C', B'. A necessary and sufficient condition that the latter projectivity hold is Q of ABC, A', B', C', by Theorem 23. Corollary 1. If an involution has double points, they are harmonic conjugates with respect to every pair of the involution. Assumptions A, E, and P. For the hypothesis A equal A', B equal B', gives at once H of AB, CC' as the condition of the theorem. Corollary 2. An involution is completely determined when two double points are given, or when one double point and one pair of conjugates are given. Assumptions A, E, and P. Corollary 3. If M, N are distinct double points of a projectivity on a line, and A', B', are any two pairs of homologous elements, the pairs MN, AB', A', are conjugate pairs of an involution. Assumptions A, E, and P. Corollary 4. If an involution has one double element, it has another distinct from the first. Assumptions A, E, H0, and P. Corollary 5. The projectivity ABCD projective with ABDC between four distinct points of a line implies the relation H of AB, CD by assumptions A, E, and P. For the projectivity is an involution, Theorem 26, of which A, B are double points. The result then follows from Corollary 1. Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.